Hello students, today we are going to solve some numericals based upon torque, angular momentum. So first we are taking a question. Find the torque of a force 9I cap plus 6J cap minus 5K cap about the origin where the force is acting on a particle whose position vector is I cap plus J cap minus K cap. The solution for the numerical. See the data given are force F is equals to 9I cap plus 6J cap minus 5K cap means the force has three components along the three dimensions x-axis, y-axis and z-axis, and the net resultant force is given by 9I cap plus 6J cap minus 5K cap, and also given the position vector of the particle denoted by small r is equals to I cap plus J cap minus K cap. The relation between torque, force and position vector is given as torque equals to vector product of position vector and the force. So finally we get torque equals to vector product of these values the position vector, its cross product with the force, we can arrange the data given for position vector and the force to product both R and F. The arrangement of the data in three dimensions for the position vector and the force can be done in the form of a determinant, where the solution for the determinant will provide the value of torque required. So we can write this torque equals to, now in this form the all data have been arranged here for the position vector and the force in terms of determinant, where now we can solve the value for the determinant for individual magnitude along the direction of the unit vectors I cap, j cap and k cap. So the solution of determinant will provide the value of the torque required, and now the torque will be minus 5 plus 6 I cap plus minus 9 plus 5 j cap plus 6 minus 9 k cap. So finally it provides the torque as I cap minus 4 j cap minus 3 k cap. This is the vector representation of the torque. Magnitude of torque will be given as square root of 1 square root of 1 square plus minus 4 whole square plus minus 3 whole square. The complete term is under the square root. So its magnitude is square root of 1 plus 16 plus 9 equals to square root of 26. which provides the value of the torque 5.1 Newton. That is our answer. Now here is another question. Question number 2. Show that the angular momentum of a single particle moving about any point with constant velocity remains constant throughout its motion. The answer is theoretical with a little bit explanation of the formula which express the relation between angular momentum, the position vector of the particle and its linear velocity. Now in this given figure, an axis is there crossing through an origin O, and the direction of axis is perpendicular to the plane of the screen which you are observing, and the particle is moving in a plane of the screen. The direction of the velocity of the particle is given here by the light green color, and the direction of the position vector of the particle is given here by dark green color. So both of the vectors representing their corresponding directions along with they are acting, and the position of particle is at point P at any instant of time. Now in this case, the linear momentum and angular momentum of the particle are correlated with each other. The perpendicular distance of the velocity of particle, which is being expressed here by a line OM, that perpendicular distance of the velocity direction with respect to the origin is given by the line OM as R sine theta, where theta is the angle between position vector and linear velocity. The linear momentum of the particle in vectorial representation is given by P equals to mv. The angular momentum of the particle, vector L, is represented by cross product of vector R and the linear momentum, or we can write this the cross product of vector R and mass multiplied vector velocity. So further, the result give us the value mvr sine theta, where the r sine theta is the perpendicular distance of the velocity direction from the axis of rotation about which the particle is rotating or moving. Since at every instant of time the position vector and the velocity of the particle are changing their direction with respect to the direction at any instant of time, another instant of time, but the angular position between the position vector and the linear velocity will be the same, means the value of the theta angle will be constant throughout its circular motion around that fixed axis or the point. So the value r sine theta will remain constant throughout its complete motion. The magnitude of velocity we are not changing. The particle is moving with constant speed. The magnitude of mass of the particle is not changing, it is constant. So if the three quantities are constant here, the mass of the particle, the speed of the particle, moving in a circular motion with uniform speed, and the component of the position vector r sin theta is also constant due to the theta angle between position vector and the velocity vector is constant throughout its complete motion. Every time the direction of the position vector is changing, the direction of the linear velocity is changing, but also at every instant of time the angular position or the angle between the position vector and the velocity are same. In that case, the r sin theta value is constant. It means the angular momentum of the particle throughout its motion will be constant. So since theta is constant between r and v vector at every instant of time, the angular momentum of the particle moving about a fixed point or origin or with uniform speed, but velocity is changing, will be constant. So that's all for today. We will continue this chapter with another topic in next turn. Till then, good day. Thank you.